Good day, and thank you for joining us at The Scientist's Perspective. On today's episode, we are going to be discussing the biochemistry of polyendocrine metabolic ovarian syndrome, PMOS. And in this video, we are going to be considering the recent change in nomenclature from polycystic ovarian syndrome, PCOS, to polyendocrine metabolic ovarian syndrome. What exactly PMOS is as a medical condition, the role of insulin and androgens in PMOS, as well as management and prevention tips. Polyendocrine metabolic ovarian syndrome was previously called the polycystic ovarian syndrome, and it affects 1 in every 8 women. Globally, we currently have about 170 million cases, and it is pertinent to note that the new nomenclature was announced earlier this year through an international consensus process that was published in The Lancet. For as many individuals that would love to peruse the original research article, I will drop a link in the description for you to follow. Moving on to the major topic of discourse, what exactly is PMOS? As earlier established, PMOS stands for polyendocrine metabolic ovarian syndrome, and for women aged 20 years and above, it is a medical condition that is characterized by at least two of the following features or symptoms. The first symptom is the occurrence of irregular or no ovulation, a medical condition that is termed oligoanovulation. And then the next characteristic feature is the excessive production of male sex hormones, which is tagged hyperandrogenism. And finally, a symptom that can accompany polyendocrine metabolic ovarian syndrome is the development of polycystic ovaries. And from this symptom, you can guess where the previous name came from. It was previously called polycystic ovarian syndrome. So it was previously diagnosed based on the presence of cysts in the ovaries. But science and research have advanced to help us understand better how that it is beyond the presence of cysts in the ovaries, but it is as a result of the dysfunction in other systems in the body, particularly the endocrine and metabolic systems. Now, in addition to or akin to the presence of polycystic ovaries is an elevated level of anti-Mullerian hormone in concentrations greater than 4 nanogram per mil as a characteristic symptom of PMOS. And this makes sense because the anti-Mullerian hormone is a protein that is produced by follicles present in the ovaries. So the higher the amount of the follicles, the greater the concentration of anti-Mullerian hormone present, helping us to infer the presence of cysts in the ovaries. So for individuals or for adolescents that are aged between 10 to 19 years, they require the first two symptoms to be diagnosed with PMOS. That is, they must have an occurrence of irregular or no ovulation, as well as an hyperproduction of male sex hormones. Moving on to the pathophysiology of endocrine metabolic ovarian syndrome, it is pertinent to note, as earlier established, that it involves the aberrant um, expression of certain entities or elements in the endocrine system as well as the metabolic system. So this implicates important hormones like insulins, androgens, as well as ovarian hormones. So starting with insulin, as we all know, insulin is an hormone that plays pivotal roles in carbohydrate metabolism. It is the major secondary messenger that is deployed in events of an influx of sugars into the bloodstream, and its major role is to activate muscles and the liver cells to initiate the process of sugar conversion into energy. But in cases where the body is resistant to insulin and then there's an influx of sugars into the system, the body might be forced to produce more insulin to complement for the body's inability to utilize the already available or the already secreted insulin, and this might result in the ultimate accumulation of excessive amounts of insulin in the blood, a medical condition termed hyperinsulinemia. So once an individual has hyperinsulinemia, it becomes a precursor to other metabolic disorders, because insulin in the body can then proceed to act as a gonadotropic hormone in the ovary. It activates the thicker cells to stimulate the production of androgens, and similarly it can cause the luteinizing of granulosa cells and then results in the strings of pills that would later come to see on scans for people that have polyendocrine metabolic ovarian syndrome. Additionally, once insulin or once hyperinsulinemia exists in an individual's body, and it has initiated the process of excessive androgen production, it also signals the liver to halt the production of sex hormone binding globulin, which is a protein that kind of acts as a mob for globulins present in the blood. So basically, insulin acts as an activator for androgen synthesis, and at the same time acts as a suppressor for proteins that are supposed to eliminate excessive androgens in the body. Moving on to androgens themselves. So as we know, androgens are male sex hormones, and as a result of the activity of insulin on the ovaries, there is an heightened or an increased level of production of these androgens. And ultimately, with increase in production of some of these androgens, what happens is that the brain's sensitivity to progesterone um, is changed, and it is altered to favor the production of luteinizing hormone. And then, the fault production or the increased ratio of luteinizing hormone compared to follicle stimulating hormone aids the production of more androgens. And ultimately, an heightened or an increased level of androgen production would clinically manifest itself in individuals, with symptoms of them having hairs all over their body, hirsutism, or being bowed, alopecia, or then they having acne and other features on their face. So moving on to the vicious pathological cycle of polyendocrine metabolic ovarian syndrome. As we've established, it starts with the body not being able to effectively utilize insulin for carbohydrate or sugar metabolism, and then this results in a medical condition called hyperinsulinemia, whereby the body has produced more insulin than what is needed, and then the body cells are unable to effectively utilize or bind this insulin. This ultimately results in the formation of excess androgens as a result of insulin activating the ovaries, but it also triggers the suppression of steroid hormone binding globulin in the liver, thereby ultimately resulting in an excessive amount of androgens being produced and being in circulation in the bloodstream. Ultimately, the excessive production of androgens will lead in the accumulation of visceral fats, and then we all know that visceral fat accumulation is a precursor to insulin resistance, and then this vicious cycle continues up to the point that we start to see clinical manifestations of polyendocrine metabolic ovarian syndrome. So how do we manage PMOS, or how can we prevent PMOS? For healthy individuals, it is pertinent to note that their body mass index has a direct relation with, at least for ladies, has a direct relation with their tendencies to develop endocrine metabolic ovarian syndrome. Thereby, it is pertinent for them to maintain healthy diets, to regularly check their weight, as well as to involve in physical activities rather, and then routine medical checks that help them to check for unexplained weight gain, um, you know, um, insulin, the early onset of insulin resistance, as well as other conditions that might predispose them to polyendocrine metabolic ovarian syndrome. And for people that already have polyendocrine metabolic ovarian syndrome, lifestyle modifications are highly advised. Change in diet, avoidance of a sedentary lifestyle, as well as the use of medications and hormonal therapies to complement the ongoing efforts to reduce the amount of insulin in circulation. So thank you very much for joining us on today's episode. We look forward to seeing you next time on another episode of The Scientist's Perspective.